Good morning, grade 7s. Today we are learning about area of circles. Now, there is a video that I am going to post on Google Classroom, which talks about where the formula for area of circles comes from. Okay, so if you are the type of student who is very curious and always has to know these type of things, please go ahead and check out that video. But the video is optional, okay? And the reason why is that in my experience, I have found that going through the proof for why this formula works the way it works tends to confuse more students than it helps. So consider that kind of an advanced add-on. If you're interested in this formula and how it works, go ahead, watch that tutorial video, all right? Otherwise, I am simply going to ask you to take this formula from me on faith, okay? Trust me and say that it does in fact work and just go ahead and use it. All right, so the formula that we're using to calculate area of a circle is this. The area of a circle is equal to pi, yep, there's that number again, we're still using pi, times the radius, and wait for it, this one's a little funky, squared. Okay, now we talked very briefly about exponents in our decimals section of the unit when we talked about BEDMAS, and I said the E stands for exponents, and we went over it briefly, but I didn't make you do a ton of problems with exponents, okay? We're going to talk about exponents again now, all right? So what this little 2 here means, what this squared means, is that you are going to multiply this by itself. So a slightly different way of writing this formula is that it is pi times whatever the radius is times whatever the radius is, okay? R squared means the radius times the radius. It's R times R. Now, on a practical level, what does this look like? Well, we have a problem right over here on the board. We have a circle. Its radius, the distance from the center to the edge, is 5 centimeters. I can plug my numbers in here, okay? So area is equal to pi, which is 3.14, and this actually is a number you should memorize. You should have 3.414 memorized as the number that pi is worth. It's not a precise value, but that's what we tell people to memorize for pi, times 5 times 5, okay? And so we do exponents first, right? When we talk about BEDMAS, we do exponents first, and that's why I put this in brackets so that we would multiply that first. 5 times 5 is 25, and that multiplied by 3.14. We are going to have to do some math here on the board. We're multiplying 3.14 times 25. 4 times 5 is 20, carry the 2. 5 times 1 is 5, plus 2 is 7. 5 plus 3 is 15. Now remember, we're moving over one place. So this means that the next row is going to be 10 times bigger than this one was. So that's why we add this 0 down here to shift the place value over 1. Now we go 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. And we add those. Boom, 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 boom. And our answer is 78.50. So our area for this circle is 78. I'm just gonna, well, no, we'll say that this is accurate to the hundredths because it is. I'll leave the 0 in place. And this is centimeters squared. Now remember again, it's centimeters squared. It's not this number squared. I had a few people in the area of triangles unit started writing a 2 here. That's not what we're talking about here, okay? This is square units. If you put a square on this number, then we're doing this, right? You have to multiply it by itself. That's not what we mean. Okay, so this is a first example here. We got 78.50 centimeters squared, 78 and 50 hundredths, okay, centimeters squared. Now I want to talk a little bit more about these exponents. They aren't always just 2's, okay? So if, for example, I wanted to know what 5, we call this cubed, 5 to the power of 3 was, it is equal to 5 times 5 times 5. So you've got 3 5s and you multiply them, okay? Basically, 5 squared, as we mentioned, is 5 times 5. Guess what 5 to the power of 4 is? That's right, you got it. It's 4 5s, and we multiply them, right? 1 5, 2 5s, 3 5s, 4 5s, okay? Exponents aren't difficult, all right? They're not complicated. We're only going to be using squares this year. We're not going to be doing cubes. We're not going to be doing to higher powers. We're just going to do squares. The really critical thing here is that you remember that when we square something, we times it by itself, because every year I have a student, I ask them, hey, what is 5 squared? And they tell me 10. No, that's 5 times 2. If I wanted 5 times 2, I would have asked for 5 times 2. Okay, I'm going to erase this, and we're going to do one more example problem. Let's suppose that we had a radius of 3 meters. Sure, why not? Okay, I'm going to give you a whole new here. So we have a circle with a radius of 3 meters. Once again, we're going to write our formula. Area is pi r squared. Plug your numbers in there. Area is 3.14 times 3 squared. Uh-oh, I got to remember, what does it mean to square something? It means I multiply it by itself, right? So this isn't going to be 3 squared. It's going to be 3 times 3. It's the same thing, okay? So you should be able to think to yourself, 3 times 3 is 9, right? So this is 9 times 3.14. So our area here, I can do an estimate here. 3 times 9 is going to be about 27, but let's do the calculation as well. 3.14 times 9, probably blocking this. All right, 4 times 9 is 36. Write the 3, 6, carry the 3. 9 times 1 is 9, plus 3 is 12. Carry the 1. 9 times 3 is 27, plus 8 is 28. And we got 2 decimal points, so 2 decimal points. And I was right with my estimate. My estimate was 27. So this is pretty much bang on. Area is 28.26 meters squared. That's 28 and 26 hundredths of a square meter. All right, so you have some work to do. Remember, we do not learn math without doing the practice. I have another video I'm going to post for you for the second worksheet, which uses diameter to calculate area instead of radius. It's not harder. Oh, there's just one extra step. Okay, so do the first worksheet first, and then I'll see you again.